Hello viewers, thanks for being back. In this episode, we upgrade the Scenic Pro C5 PC that we restored in the previous session. If you haven't watched that video, please find it linked below. I'm going for a 9.1GB IBM SCSI hard disk and a Toshiba CD-ROM drive instead of the ID parts that were in this computer. For this, we need some SCSI cables and a SCSI host adapter. We will use an Adaptec 2940 U2 WPCI card. It has two SCSI channels, one ultra-wide 68-pin with up to 80 megabytes per second transfer rate, and one narrow 50-pin SCSI channel for slower devices like our Toshiba CD-ROM. If you are familiar with SCSI, please feel free to skip ahead. SCSI is a bus-based system that allows up to 7 devices to be connected on a narrow and up to 15 on a wide channel. Each device requires a unique ID that is typically set with jumpers, and the bus needs to be terminated on each end by installing a resistor pack or by a jumper setting. In this case, I connect the hard disk to the ultra-wide channel to exploit its speed, and the slow CD-ROM drive goes on the narrow channel. If we were to connect both to the same channel, then the slowest device dictates the highest possible speed. We will also install a network adapter, which in this case is a 3-COM Etherlink XLPCI card. I got a video RAM upgrade for the onboard Cirrus Logic 5446 video controller. These are two 256K x16 chips. I bought the cheapest ones off eBay, and I hope they work. For sound, we will use a cheap Vibra 16 Acer card. I start with the 50-pin SCSI cable that goes to the CD-ROM drive. Then I attach the 68-pin ultra-wide cable to the hard disk. It has a built-in terminator on the last connector, which is very convenient. Of course, I disabled the termination on the hard disk. Next is the Vibra 16 sound card, because it goes into the bottom slot. Next up is the 3-COM network card that goes into the second PCI slot. This computer does not use screws to hold the expansion cards in place. Instead, you need to install the white clamps. Now I connect the 50-pin SCSI cable to the Adaptec controller, and then I install it into the top PCI slot. Here comes the clamp to hold the card in place. And then I notice my mistake. I should have installed the video RAM first. Now the sockets are covered with the expansion cards. Oh cock. I remove the PCI cards to free up enough space to work on the video RAM. Then I use some contact cleaner on the sockets to remove possible oxidation. The chips go into the sockets by just pressing them down. Only thing to be careful about is the orientation, which is indicated on the chip by a notch and on the socket by the angled side. It's also a good idea to look at the chips on the motherboard. Likely the new chips should point into the same direction. After this little oversight, I put the PCI card back in, and then I install the hard disk, which sits in this bridge. Here comes the 68-pin SCSI cable to connect the hard disk to the Adaptec controller. The space in here is a bit tight for all these cables. I have to take care not to pinch them. Great, the reassembly is done. Let's test if everything works before we button this up. Looks good. It posts, identifies the SCSI devices, it seeks the floppy drive and spins the CD-ROM. Let's bring up the setup menu that's built into the Adaptec BIOS with Control A. Let's first reset the controller to factory default values so we have a known baseline to start with. Then let's look at the termination setting of each channel. The controller will automatically terminate both buses on its end, which is fine. We leave this setting as it is. The boot device ID identifies the SCSI device from which the system will try to load an operating system. The default is fine since we jumpered the hard disk to ID 0. Then we look at the advanced settings, which are fine as well. The adapter supports booting from a CD-ROM drive, and it will reroute interrupt 13 routines, which is needed for MS-DOS programs that use the BIOS for disk access. Let's now exit out of the configuration menu and bring up the SCSI Disk utilities. We can verify and low-level format disks from here. The hard disk was used in a Unix workstation previously, so let's now wipe it clean. About 10 minutes later, the format is complete. I'm going with a Windows 98 install to try out the new upgrades. We'll speed this up quite a bit by the magic of video editing, so you don't have to sit and wait for the 35 minutes this took. Wait, shouldn't there be sound? Windows startup fanfares and everything? Where is it? I should have inspected the sound card more closely. Turns out the eBay seller who claimed it was in working order can't have tested it because it's incorrectly jumpered. This jumper block activates or disables the amplifier, but in this configuration, the audio channels are shorted and not connected to anything. The correct setting is shown in the user manual and for line out, which is what I want for active speakers. 2 vertical jumpers have to be installed in the lower position. So I opened up the box once more, pulled the Vibra 16 sound card out and corrected the jumper settings. And now, would you listen to that? Windows fanfares and music at full blast. Okay, the audio card works. How about our video RAM upgrade? Let's check the adapter configuration in the system control panel. Yes, it shows 2 megabytes of video memory here, which gives us more than 256 colors in higher resolution modes. Nice. Now let's check if the network card works. This browser is clearly too old to surf the web, with the exception of retro websites. Let's check out Action Retro's FrogFind search engine. Okay, that works. So I should be able to find my SMB server in the network neighborhood and download some software to this box for further testing. Here is something appropriate: Doom and Doom 2. Let's copy them over. Let's fire up Doom to see how it works on this box. Alright, that works. This video is long enough already, so thank you very much for watching. If you enjoy this content, then please like and subscribe. Bye until next week.